In 6.3, problem number 11, we're asked to convert these odds to probability, and we do know this, that if we write the probability of that event, it's going to look like this fraction. Now, this number here, 10, these numbers 10 to 1, the 10 is going to appear on top, and then in the first position in the bottom. So it's going to look like this, 10 over 10 plus 1, right? These numbers here are going to match. So we're going to take this bigger number, break it down into two numbers, this bigger number, break it into two numbers, 10 to 1, put that on the bottom. So we're going to come out here with 10 out of 11. And in part B, we want to convert these odds, 1 to 2, for an event to the corresponding probability. So we could write this. The probability of that event is, now we know that this goes in the denominator with the 2 becoming the plus sign. So this is going to be a 1 plus 2 in the denominator. And in the top, this first number here matches that number in the top. So that first number is a 1, so we're going to have a 1 up there. So this is going to be 1/3. And then let's interpret this meeting. This says that if we were to perform this experiment three times, we would expect a 1 of those to be the event. And what this says is that if we, for every 1 time the event occurs, there's 2 times it doesn't. So we're really performing the experiment 3 times. It occurs once out of those 3, and that's what is shown here. And in problem number 12, we're told that in poker, the probability of getting jacks or better is about 1/6. And what we want to know, what are the corresponding odds? So let's say this. We can say that the odds for jacks or better are 1 to 6. And what it means is this. For every 1 time you get jacks or better, there's 6 times that you don't. Problem number 14 says that the odds of Americans living in the state where they were born is 17 to 8. What is the probability that an American selected at random lives in his or her birth state? So the probability is going to be, now it's a fraction, and we know we're going to write this, 17 to 8. The 2 becomes a plus sign. This goes in the denominator, so this is going to be 17 plus 8, and the numerator matches that number right there. So let's write our numerator, right? We want to match here. So let's write a 17 there. So this is going to be 17 over 25. In problem 18, here's what we're given. We are given that the probability of some event E is 0.4, probability of some event F is 0.5, and the probability that E occurs and F does not is 0.3. And then we're asked some questions. So right up front, why don't we draw a Venn diagram and see if that'll help us out here. So I've got my 2 circles. Here's E and here's F. Let's fill these in. So what we do know here is that the probability of E is 0.4, but we know we start filling in from the outer as much as we can, from the inner as much as we can. Now here's what we know. The probability that E occurs and F does not. Now that's right in here. All right, that's you're in E, but outside of F, and we're told that that probability is 0.3. And now we know this, the probability of E all in all is 0.4. We've already accounted now for 0.3 of it. So in here must be a 0.1. And now we're told here that the probability of F is 0.5. So all in all, total F is 0.5. We have already accounted for 0.1. So outside here must be a 0.4. Now we still need to get this region out here. So what have we got so far? We've got 0.3, 0.1 is 0.4, another 0.4 is a 0.8. The whole thing is a 1, so this out here must be 1 minus 0.8, or 0.2. Now in part A of this problem, we are asked, what is the probability of E intersect F? And now since we have our picture, we can just look for it. Here's the intersection right here, so we'll claim that to be 0.1. And then in part B, what we're asked is, what is the probability of E or F? Now this is just a union, so that's going to be everything that's an E as well as f, we're going to get a 0.3, 0.1, and 0.4. You add those up, there's our 0.8. Now in problem 21, Joe feels the probability of his getting an A in history is 0.7. So, you know what we need to do here is we need to come up with some notation for this to remind us that this is an A in history. So you can come up with anything you like. I'm just going to write this to remind me. History, Joe gets an A. And what we want to know is what's the probability of getting, what we're trying to do here is find the probability of getting an A in history and an A in psychology. Now, you might try a Venn diagram for this. I'm going to go back to an old formula that we have, which is this. The probability of H, I'm just going to skip the A's, H or P is equal to the individuals, the probability of H plus the probability of P minus the probability of H intersect P. Now we have these numbers. This one over here, the union, that's a 0.9, and that's equal to 0.7 plus 0.8 minus the probability of both of them, H intersect P. Oh, it's getting a little tight here. So now we're going to have this 0.9 equals 1.5 minus the probability of H intersect P. Subtract, we'll get negative 0.6 equals negative the probability of H intersect P. Multiplying both sides by negative 1, we'll get the probability of both an A in history and an A in psychology is 0.6.